the 1970s, Bill Fox, a QuarryVision manager for Ready Mix Australia, first began implementing his quarry performance optimization methods. Fox believed that before any aggregates operation could begin to optimize performance, it was absolutely necessary to develop and maintain certain organized procedures directed at achieving maximum yield of key products, while minimizing byproducts and waste. This was the only way to obtain the lowest operating cost per ton of finished products. Foxy, as he is known, is shown here on the right of your screen in Sydney, Australia, with Jeff Harris. Harris was among the original group of Australian aggregate managers to be trained by Foxy. In the 1990s, Harris became the CEO of the American Aggregates division of CSR, bringing the Ready Mix system to the United States. Under Harris' direction, Alan Besson, Vice President in charge of engineering and technical support, began the process of incorporating and expanding the system to include key procedures focused on balancing sales, production and inventory. At the time, American Aggregates had annual sales of approximately 24 million tons, in 38 plants, generating $116 million in sales revenues. Aggregate inventory value, expressed as a percentage of total annual revenues, was running at 11.5%, representing approximately 5.7 million tons. With a focus on sales production mix optimization, the inventory versus revenue ratio dropped to less than 8%, achieving a reduction of just under 2 million tons by the close of the second business year. This generated significant variable cost savings as the yields of the key driving products were at last being measured. Over the last 20 years, all of these principles and procedures have evolved into a state-of-the-art real-time measurement, management and optimization system, QuarryVision. Based on the belief that you can't manage what you can't control, you can't control what you don't measure, so if you don't measure your process, you can't manage it. Before the introduction of the QuarryVision systems, the aggregates industry had few choices when it came to tools to effectively evaluate, measure or control the production process. Most process control applications are, in reality, limited to the regulation of start-stop sequencing, feed rate control, bin level monitoring, overload protection and energy measurement. The industry's mainstay measurement tool has been belt cuts and sieve sampling. These methods are widely accepted as a tool for product quality control. The process begins with the selection of belts to sample, bringing the operation to a stop, then using a shovel and brush to manually remove the product from the selected belt cuts. The sample is then sent to a lab where a technician analyzes each sample, and then in a few hours, or days in the case of multiple samples, the production manager receives the results. But, belt cuts and sieve samples cannot be relied upon for controlling the production process, and here's why. Look at what a belt cut represents. For example, if you take one belt cut per shift from a 400 ton per hour plant, that cut represents approximately 228 pounds or 0.029% of the plant's 3,200 tons of daily production. The data resulting from a 228-pound belt cut is simply inadequate as a representative sample of the thousands of tons of product produced daily by a plant. Even 4 belt samples would still only give you a look at less than 1/2 of 1 ton of daily production. A belt cut provides only a single gradation snapshot. To achieve definitive production management, QuarryVision continuously records yield, rate and runtime data for the entire process. Flow modeling simulation software is another tool used in the aggregates industry. While this tool is excellent for plant design, it is inappropriate for managing or controlling the production process. All flow modeling software used in the aggregates industry are steady-state simulation programs. Steady state refers to any process that runs in a continuously stable condition and does not change over time. Consequently, all flow modeling software is programmed to presume that the production process is run continuously in an unalterable condition. Flow modeling software also depends upon performance data furnished by equipment manufacturers who conduct their testing under strictly controlled circumstances. This is why equipment manufacturers provide product disclaimers, and the same is true for flow modeling software developers. Equipment disclaimers explain that unless you operate under the same conditions used during testing, you cannot expect the same production results. Flow modeling software disclaimers warn users that simulated results are based on optimal operating conditions and that it is the user's responsibility to verify that the input data is valid and operating conditions are optimal. The real world of aggregates production is not a steady-state process. Real-time production reporting demonstrates this fact. This flow model shows the finished production segment of a currently operating 1,000 ton per hour rated plant. This is an image from the QuarryVision real-time reporting system displaying actual production from the plant just shown in the flow model. This 10-minute snapshot shows what appears to be a steady-state process, capable of achieving its design rate of 1,000 tons per hour. However, as the rest of the day is exposed, it immediately becomes obvious that the steady-state presumption used in flow modeling software does not represent operating reality. These are QuarryVision production charts, captured at 1-minute intervals, from 5 continuous days of processing at a 1,000 ton per hour design-rated plant. The green line in each report reflects the 1,000 ton per hour flow model design rate. Looking at the production days individually, you will see the highest daily average was 816 tons per hour and the lowest daily average was 429 tons per hour. The average tons per hour for the week would be 643. With QuarryVision, you will be running with the Fox, using the most powerful, intuitive, accurate performance and profit optimization system available to the aggregates industry. QuarryVision relies upon far more than unvalidated flow models, infrequent belt samples and questionable closed-side setting measurements. QuarryVision takes real-time data produced by belt scales and transforms it to reveal the true yield and capacity limits of the process. In addition, operating benchmarks are created, making it far easier for production managers to continuously measure, analyze and sustain performance. Once the true capability of an aggregates process has been established, QuarryVision blends sales data and marketing projections, thus facilitating cooperative planning between production, sales and accounting managers. Key features of the QuarryVision system includes a historical database that precisely reveals performance benchmarks as well as hidden patterns, trends, process bottlenecks and undesirable variability. A real-time data interface which provides continuous performance feedback, including the ability to evaluate the effect of various plant configurations on key product and byproduct yield. Custom reports and alarms, including real-time management updates and alerts triggered by user-specified events or by time of day. A web-accessible real-time interface, including smartphone and tablet, indicating achieved yield, capacity and variability for each product as well as for individual process segments from primary to stockpile. The initial measurement system is comprised exclusively of belt scales strategically located to measure key elements within each segment of the process. The profit optimization model includes process measurement, cost management, mode validation, inventory management, and utilizes sales projections and revenue forecasts to project potential profit margin within various operating and sourcing scenarios. QuarryVision was designed and created exclusively for the aggregates industry. There is no shrink-wrapped software that can compete with its reliability. The QuarryVision system can truly bring an end to speculative forecasting, out-of-balance budgets, and end-of-year accounting nightmares.